Hello. Hi. I can see most of the people who subscribed have joined, so I'm gonna kick off the webinar. Um, Small disclaimer: this is our first webinar, so if things go wrong, our apologies. We're still learning. So this webinar is going to talk about the benefits of data technologies on quoting and pricing, or on the utility industry as a whole, maybe as well. Okay, this is me. I'm Joris. I'm the product director at Gorilla. Gorilla is actually a product utility pricing engine, actually, but at its core, it's really a data processing engine, which we built from a technology point of view, because we saw some challenges in the utility space. So hence, I wanted to share what we've learned or what we've seen over the last year, talking to a lot of companies in and outside utilities, in the different countries as well, in terms of what's been happening with technology and how we could go a bit further. There should be a Q&A button somewhere on your screen, I think at the bottom. So if you do have any questions during the presentation, we have a Q&A, some time for Q&A reserved at the end of the presentation, but do put in your questions there. Willem is here, he's my co-host, so he might already answer some of the questions during the presentation, or we can pick them up at the end. Good, so let's have a look at the agenda. I'm quickly going to talk about the B2B utility market, kind of to bring it into context, to kind of explain, and most of you will already know this, how we got to where we are today. So what influences are playing on the suppliers today and are playing on the market today. Second point, I'm going to talk about the challenges that brings, specifically, or most specifically, on pricing and quoting and forecasting, and what technological opportunities there are to change those processes. And then in the third point, I'm going to recap the benefits that I've touched upon in point number 2, and I'm going to show some or talk about some scenarios that are now enabled by these new technologies. And then at the end, we've saved some time for a Q&A. Okay, so let us start with the B2B utility market. First thing I think everyone already knows is that the markets are opening up. So they used to be, for scale economies, they would be large centralized generation, which would be completely vertically integrated. So you would have big generators that would also be the suppliers that would basically cover a whole country or a very big region. And because that was the case, they typically went for really large scale software packages. Why? Really to have maximum stability, because they were responsible for like the whole country. They were mostly government owned, so they went for the big large scale software packages. As the market began to change, and I'll show you later how it kind of changed, what happened was that those large scale software packages basically got customized and customized and customized and customized, so that you get a lot of add-ons onto customizations, where the system basically got a bit abused. And then fun things that we saw as well is that when there's then mergers or acquisitions happening, that you would actually see two of those big monolithic systems within one company, even both customized completely. So a lot of utilities have a specific billing engine for power and another one for gas. Other ones might even have two separate ones for gas for one part of their customers and one for the other part of their customers, because they adopted all the systems from all the companies that joined together. So I think that's also a good first thing you have to know about how it, well, sometimes it works at these big utility players, because it will have an impact on what we talk about later. So obviously, the IT architecture of these big utilities have become steadily bigger, more cumbersome, and harder to maintain. So this is one of the forces playing onto the suppliers today. Obviously, the market opening up also means that we move away from this large centralized generation into more distributed generation. The vertical integration is in the markets that are completely open, is going completely away. If we look at the UK, there's almost no vertical integration anymore. If we look at markets like New Zealand, where we still see that like the 5 big incumbents in the market still own 90% of the generation and 90% of the supply. That's one, there are 5 companies that do 90% completely vertical, whereas all the other small ones only do the supply side. So in those markets, they're not as far. They still have the vertical integration that's been there historically, but also in these markets, there's now in New Zealand, they're really trying to cut that up as well to make the market a lot more competitive as well. In terms of the large-scale software packages, there's a lot of new technologies coming into the market, or a lot of innovations happening. So everyone will need to start adopting those technologies as well. Second thing that's happening as well within the utility space is that the costs and the risks are on the move. So it used to be that there was a large margin on the goods sold when there was like this big large company that was the only one doing it. And now with a lot more competition and the distributed generation and things, obviously costs and the risks are on the move. If we look at the first one, why this is happening is because the world is moving towards a net zero, so cutting down on fossil fuel investments. Green initiatives being heavily promoted. So basically the fuel mix is changing, which also these renewables are typically more volatile than the historic generation. So that brings a higher risk to the supplier, how to forecast these, how to sell these, how to set your risk for these. So there's a change in risk for the suppliers. And then a second one, typically these renewables have a lower production costs, so that also impacts the distribution of the commodity versus the non-commodity costs. And what we've seen in the recent years is that the non-commodity costs are becoming bigger and bigger, are becoming a larger part of the total cost of energy. So it becomes more and more important to also be forecasting these and learning what the risks are for these, and to get them better in track. I think a lot of these still today just get passed through to the end consumer. But there are already new products popping up where this is all changing. So I think those are the 2 top ones. So the market opening up, costs and risks are on the move. Obviously, they've been supported by legislation. It's a legislation that wants the markets to open up to make electricity cheaper, or gas, to make it more fair. That's also why some of the costs and risks are moving, because the legislation has told them, okay, we want to go to net zero, so we put in some rules in place to do so. So that framework has been set in place, but since it's there, it's constantly moving, it's constantly changing. So how things need to be charged, how costs are divided over the market, all these things are really changing continuously. And if we look at the UK specific, then we see with the current TCR, we can see that the transmission costs, the distribution costs, and the balancing charges are again changing. So renewables is already March of next year, duals the year after, and renewables, I think, a first change now, but there's a second task force working on changing it more. And why are they changing it? It's because of these more distributed generation. So everyone needs to pay their fair share for using the networks, transmission, distribution, but also for balancing the network. And we're only expecting this actually to grow. So all of this, which I just told you, kind of eats in on the margin of the suppliers as well. So there's a lot more risk. There's a lot more competition. The costs are constantly changing, and they basically started off with pretty monolithic big systems. So that's a bit the context of where utilities were and are today, and are trying to shift to improve it. So this brings a lot of challenges in the industry. So I'm now gonna talk a little bit about what those challenges are, and what kind of opportunities there are to solve them, mostly from a technological point of view. So let's start with flexibility. I think if you look back at one of my first slides, you saw that historically I got a question, or something is beeping. Yeah, I'm just going to continue. So historically, they started off from big monolithic systems, which are not that flexible, which means that if you want to change a cost component, change a product, those things are very, very hard to do. So what do you then do to make it flexible? Well, what we've currently seen a lot with a lot of companies is Excel. And well, Excel has its pros and its cons. It offers flexibility because in many cases, why do suppliers do this? For instance, we've seen this a lot for flex products, where basically their current system doesn't do flex products. They want to enter that market. So in Excel, they create a model and they try, okay, can we do this? How does this work? They figure out a way to do it, but then they actually start selling it without having a system. So they have to actually use the Excel to price and to bill these customers, which obviously once this grows into like a bigger part of your portfolio, brings in a high operational cost. So to maintain the Excel and to make sure it's right, it's not traceable at all, or not auditable. And it's also very bad for reporting afterwards. We've seen companies where they had to set up a dedicated reporting team for more than a week to really go through all the Excels and extend the data that was in the system, because the data in the system was only a little part, because so much was done outside of the system. But I think in essence, the idea of pulling that part out of the of your big monolithic system is right. So also, if we look at some research, or Willem did some research on all of this as well, and what it says here is that replacing complete billing, pricing, trading, and forecasting systems can take up to 5 years and more than hundreds of millions of dollars, which is really true. Instead, utilities should modernize their IT architecture and environments progressively and go gradually into a more modular approach. What does that mean? There's a lot of words that I just said. But what does that mean is, instead of completely reinventing every single system that you have, you could actually take out little parts and create specific applications for those, so you can actually manage them in a product or a system that is purposely built for it. So to give a simple example, for instance, your products. So the products, if you're a supplier, you have a set of products that you offer your end customers, like for SME products, which probably are some sort of price books. You could have some fixed INC or business products. You can have some variable or pass-through products as well. And you could even do some flex products where the customer is actually able to trade through the supplier. So what you typically see is in the big systems is that you would have these products both in your CRM or somewhat of a sales system. You would have them again in the billing system, or at least part of them. And so the ones that are passed through are there. The rest is just pulling in the prices from CRM. And then if you do trading, if you do flex products in trading, you should have some sort of product there as well, so that you know how the customer is trading and you can bill them for it. Now, if you use the best technology to do that, you could actually pull out all of these processes, which are not really processes. They are basically data processing, and because you're calculating some sort of products based on a set of data, and you're doing that in a lot of systems again and again and again, and there's a lot of impact if you want to change them everywhere. So if you want to go modular, it's actually separate those data processes from those transactional processes, and you can keep the transactional processes for now, because ICRM and a billing and a trading system, they're very good in having forms, having steps, having flows, having approvals, having document generation. They're probably already integrated with some sort of market interaction, and you could still use that. It's just a part where you need the flexibility. You could actually take that out and have a dedicated tool for that to calculate, for instance, the prices or the forecasting. So the idea of the Excel was right, but instead of just doing the Excel, you just actually take out all those bits and pieces and put them in a separate system. So if you're able to do that, so to use the right technologies for the job, you can actually very quickly create and change all your cost components. You can quickly create and update all of your products. And I think most importantly, with limited impact on the other systems. Yeah, because if the inputs and the output stores the other systems, so basically some meter data, and then yeah, the standing charge and the unit rate goes back. But in between, you can add all those additional costs, so you can have more granular data and be more flexible with how you calculate without impacting the other systems too much. It would also limit the operational inefficient workarounds, because if you have dedicated tooling, you can make it operationally efficient and keep everything in the system. So keep it fully traceable, what happens with the data. And it also obviously means that it will be easier to do reporting if you go for a more modular approach. The next one, complexity. I think is currently in many companies, it's not the main challenge today, but I wanted to put it in anyway. So complexity, I mean, is how can we do more complex things with the data? So there's so much technology is now available to do so. And we actually already see this in some companies. And what we typically see is, for instance, for the more, for the short-term forecast or for the long-term forecast, that you have some of the internal people playing around with notebooks. So notebooks are, well, they're in the data science community. There's something that's very common, very commonly used to write some more complex data processing operations in. So there is definitely a move towards those to handle that complexity. We see that as definitely a good thing, because it offers a lot of flexibility again. So you can be more flexible, you can update that quite quickly, and it offers a lot more complex operations. The downside, however, with how we see it currently used in most companies, is that if you want to use it on a lot of data, you'll need some sort of good engine to scale it, so that you can actually use a lot of the data. It needs good data to be useful, obviously, but I think that's with everything you do. If the data isn't clean, you can't use it. And I think the last one is what we see most, is that it gets stuck in the experimentation phase. So where companies would do this, and then they would have a better forecast, and they would say, yes, our MAPE is now better, but I cannot run this on the full portfolio, and I have no idea how I can now put this into the actual product or automate this into our systems. So it's more of a, we do this as a check, and then we play around with it a little bit, and then we maybe update part of our system with the data coming out of this. So it doesn't really get used the way it should. But if you combine like these notebooks with the modular approach, then it would be possible to actually start using these in production. Okay, moving on. Okay, yeah, some of the benefits. So be able to use more complex forecasting models and add things like seasonalities, or even there's a lot of, within the notebooks, there's a lot of standard algorithms already available which you can use for forecasting. So you can just adapt to what you need. Anomaly detection, there's also some algorithms to do that. And while keeping it fairly transparent, because these notebooks are, yeah, they're notebooks with the code in them separated, so you can easily see what's been done. And that brings us to the third one, which is about data storage and availability. So I think in this space, a lot of innovation has been done. So there's a lot of data lakes and data warehouses available. There's also a lot of data pipelines and data ingestion methodologies and streaming data and those type of things. And we also see these being implemented as well more and more within the industry, which is definitely a good thing. How we see that happening today is kind of like this. So where so on the left, you have your CRM, your billing, your trading, your pricing, all your systems. And they would actually dump every night or in like a batch job, would dump a lot of the information into the data lake. And sometimes this is overnight, sometimes this can be during the day. That information is then stored in the data lake. And already there, I think that's an important step where you need to be very clear on how you put the data in there. Because we've seen systems that would, on every accepted quote, would take a full snapshot of all the input cost curves and the commodity curve and everything that goes in it and put that in the data lake. But that means that the data lake was huge and it's so much data, but like half of it was duplicates. So which obviously is not the right way to do it. But again, there's now a lot of methodologies to timestamp and version and build good reference libraries so you can very optimally store this data. And then typically what would happen afterwards is on that data lake, afterwards there would be a batch job at night which would run some reporting. But that would mean by the time you could use that reporting, you're already a day behind the facts. So the data lake technology and the data technology has evolved really so that you can actually, instead of doing this in a batch, you can actually, although it's massive amounts of data, you can actually query it rather quickly. So you don't have to do this overnight anymore. And you can actually move this into an event-driven system. What does an event-driven system mean is really, you can, for instance, once a contract has been signed, you could actually say, okay, then we forecast that again, we add that to our long-term forecast, to our position now updates, and we run the position reporting as a trigger on that. That position reporting is now available for trading, so trading has a live view on the current position. Same thing, every time a quote gets accepted, we could forecast what we expect to earn from it, put that in the lake, we can report, run our margin reporting and see, okay, what are our expected margins for the time to come. So instead of running a day behind on your reporting, you could actually make all of that a live process where you could do all of that ad hoc. What benefits does that bring? So yeah, real-time access to current position, to current margin, to current risks. I put some examples here. So a trade happens, the position can be updated automatically and be available for the rest of the system. Contract is signed, forecast is updated, position is updated, cost, risk, and margin reports are updated, so it can all triple down every time something happens. So same thing, commodity curve is expired, fixed hedging gets done against that commodity curve for all the accepted quotes. Position is updated accordingly, cost, risks, and margin reports are updated accordingly, giving you a continuous live view. And another big one is obviously that if all systems have live access to all of the latest versions of this data, they can use that in their decision making. So really improving the decision making within those systems. So making sure you're actually taking decisions on what you know today and not on what you knew yesterday. And then the last one is on performance and scalability. I think obviously I've talked about all the other ones before, so the flexibility, the complexity, and the data and the data availability. Obviously, if you want to do all these things, you need to be able to scale it. If you want to do it on all your data, and you need to be able to do it performantly if you want to do it. And also their technology has really moved on. I'm not gonna tell you how exactly that all works, but it's about I/O optimization, it's, distributed clusters, it's memory optimization, and some other tricks that you can use. And we've been actually playing around with this and doing this. So what we've seen today as challenges that are mostly to do with performance in our view. It's about these very large quotes that take super long or don't even work. We have seen workarounds where they could only do up to 200 meters, I think. And then if they had customers that had more, they basically had to offer them multiple contracts of each 200 meters to be able to run it through their pricing and billing system. Long-term forecasts that take a full night to run. That's also something that we commonly see. Reporting that takes a full night to run with a batch job, and then we hope that in the morning at 6 o'clock or 7 o'clock, the reporting is finished and hasn't failed. Reporting being done on aggregated data, so where we see that instead of really using the full granularity to run your reports, we're going to aggregate them up a bit higher to be able to handle the amount of data. And as well, some simulations where you want to look at the impact of some cost changes or new cost components coming that are run on really small sample data sets instead of on a real data set. And if you use the new technologies available, those large plus 1,000-meter quotes are no longer an issue. They run in minutes. We even played around with the long-term forecast. That also, you can get that to run in a couple of minutes as well. Reporting, as I already mentioned in the data part, can actually run on an ad hoc basis as well, and can also, depending on the size of the reporting, can happen in minutes or seconds. Reporting can be done on the full granularity of the data. And you can actually start running simulations on real data sets or on real products that are going to be impacted, rather than just on a sample set on the site. Good. I hope I didn't rush through it too quickly, because I typically do. But let's now revisit the benefits, and then let's talk a little bit about some scenarios that now enables within the industry. So we talked about flexibility. So if you go from, if you separate out your data processing part, so the pricing, quoting, forecasting, some trading is also about data processing. And if you move that out of your transactional systems and have a dedicated data processing system, you can actually win a lot on flexibility. So it will allow you to very quickly create, change, update cost components or cost elements. It will allow you to get a lot more creative with your products, so to quickly create and update them, whilst limiting the impact on the other systems, which I think is very, very important. It will limit the operational inefficient workarounds. It will limit all the Excel flows that you have, because you can now have it in a dedicated system. And keeping it within the system will also allow you to stay fully traceable and auditable in terms of what data was used and for which quotes and for which bills or forecast. And it will also allow for a lot easier reporting. And I think maybe one thing that isn't on here, but that we've also seen as a bit of a benefit, if you go for a more modular approach, there's a much cleaner split in ownership between the sales user, for instance, that works in a CRM, and your pricing team that works in your dedicated pricing system. So because we've seen scenarios where salespeople had to come into the pricing system and do a couple of the steps, and then the pricing team had to take over and do a couple of steps, making it really inefficient and making it operationally very difficult to manage those flows. So these are some of the benefits of going modular, and will allow you for a lot more flexibility. Complexity, so using the latest data science technologies, you will be able to do a lot more complex operations, like more complex forecasting models, seasonalities, anomaly detection, while still keeping it relatively transparent. It obviously is more complex, but again, these notebooks really offer that it's really, you know what's happening. It's not a black box, it's accessible. And well, you need to have some knowledge to see what's in there, but it's widely accepted in the community. Data storage and availability. So again, the benefits here are real-time access to a lot of, all of the data really. So current position, margin, risk, reporting, event-driven things that can now happen. So position can be updated right when a trade, after a trade has happened. Long-term forecast, position, and cost and risks and margins can be updated every time a contract is signed. Bills can go out once meter data comes in. Hedging can be done once the commodity curve expired, which will update the position, which will update the cost and margin, and so on, and so on, and so on. And obviously, new technologies allow you to really have all the systems to have live access to the latest and best version of the data for their decision processes. So hopefully this will make for better decisions. And then the last one is performance. So again, some of the benefits, if you go for these large clusters and big engines, you could have very big quotes run really quickly. So on the big tenders, you might be the first one to be able to submit, which is always good if you're first. You could run your long-term forecast, for instance, in a couple of minutes, which open up some opportunities to run multiple and then compare. You could run your reporting in minutes or available on request, so in ad hoc situations, so you have that current view of your data. You can do the reporting on the full granularity, so you don't have to aggregate out any things anymore, so you can really go completely down. And you can actually run simulations on real data sets, like for instance, what if the tenuos and the duos now change? Let's take a part of our portfolio, let's requote using these new costs, and let's see how that compares to what they're currently charged. So kind of run that on a real full portfolio or parts on your portfolio, because your system can actually handle that scale of running a lot of those codes at the same time. If we then look at some simple scenarios disenabled, let's start with, for instance, price books. This is obviously a very simple scenario, but by generating those price books in a data processing system, you can actually run them. Yeah, you can have a lot of price books, so make them very specific, make them almost bespoke. And you could update them as much as you want. So instead of doing like one price book every month and then updating it, you could actually just run it weekly or daily, or when you see that costs are changing, so we need to update them, you could just run them and then you'll have updated price books. You could add in to something to revalidate your margins. So basically what you could do is when one of this is mostly for smaller, for SME customers. At the point the SME submits, okay, I want a price at this price from the price book. You could actually run a bespoke quote at that time for that for these meters, and then compare to the price books and see, okay, is that margin still good enough? So price book versus a bespoke quote for this user, and you could do that actually there on the spot without slowing the whole system down. But then you know at that point, okay, should I take this contract, yes or no? So it would potentially save a lot of money, because we've seen today that many of them just put out the price books, accept any quote against the price books, and then a month after kind of review, did we make any money now of these price books, yes or no? While you can actually do this now on the spot. Yeah, another very simple scenario is this, just doing your point of sale forecast and your quote at the full granularity of your data, fully bespoke from within that system, so you can easily make multiple products available as well, and your CRM flow basically stays the same towards your leads or for your salespeople, but in the back you can create more products, you can innovate on your point of sale forecast, you can innovate on the products you offer, and so on and so on. Taking it a bit further already, making it more complex of a scenario that you could do, again, by separating the data from data processing from the transactional and then combining all that data together, you could actually have your pricing and your quoting, so your calculation of your products being used by CRM and billing. That means that you could make any element, any cost element, a pass-through element. That would mean that as soon as you update one cost element, it's both available for your CRM system as well as for your billing system. So you don't have to, what we've seen is some workarounds where CRM would create, or marketing would create a new product, but then companies wouldn't be able to bill it because they couldn't calculate it at the time of billing. But by separating it out and focusing on your data processing separately, you could actually do that because it just needs to be updated once. And in this example here, you could also connect up your trading system and put the data in your data processing system as well. And then you could calculate the flex commodity costs and put that into your, connect that up to your billing as well, because all that data is now shared between those systems. Yeah, and at the same time here, one of the other bullet points here as well that I see is you also can have better insights in your actuals versus your quoted margins, because you could actually rerun your quotes when you do your billing. And so rerun your quotes as if they were fully passed through. So you can actually compare, this is what they're now being billed versus if they were fully passed through, this is what they would actually be charged. So you can compare how much is that going away from each other, or how close is that. Then I have some more advanced scenarios which you could potentially do with these new technologies. So for instance, long-term forecast variations. We did some experiments and we were able to get a 5-year long-term forecast bottom up for 100,000 meters running in 3 minutes. So if you're able to do this, you could actually have multiple runs of that forecast and play around with a lot of the parameters on that forecast, so like the economic and the customer churn wedges, and kind of see in different scenarios how your forecast would move, so that you can actually make better decisions on how to hedge. And because it's a bottom-up forecast, you could actually aggregate it at every level, so at like purchasing level, or at a product level, or at a customer segment level, and then look at how that all moves, and then combine them differently together. But I think if you can play around with your long-term forecast like that and get it better, you could actually have big financial implications because you can do your hedging a lot better. A second more advanced scenario that you could potentially do is shape your portfolio, or try to kind of shape your portfolio. Like when all the forecast and the trading data is available, so your current position is always known and you know how it will grow, you could actually use that during quoting to actually look at the quality of your point of sale forecast and see how that matches up with your current portfolio. And if that matches up fine, so that it would decrease your balancing cost, you could actually discount your customer or that quote at that time as well, so that it actually brings your total portfolio better. And you could do this by giving discounts on the balancing cost or anything like that. Same thing you could do for your flex customers. You could actually kind of push them to trade in a certain way, so that it brings value to your complete portfolio, so the company portfolio, rather than the portfolio of the individual flex customer. A third more advanced scenario that I have here, and there's probably many more, and I think you guys will know, we'll be able to come up with a lot more scenarios here as well. Is, for instance, to forecast for every quote that's accepted, to forecast out how your cost recovery would go over time. And you could actually compare that to what's coming in from billing. And then for every quote or product or user segment or customer segment or business type, you could actually go look at, okay, what are the gaps? Where are the biggest gaps for each individual cost component? And based on that, start playing around with those risks. So for instance, make a certain cost component have a higher risk for a certain segment of customers because they introduce the biggest gap. And that way you can actually become more attractive to predictable customers because you can discount them, and less attractive to more unpredictable customers because they will have to pay more risk because they also represent more risk for your company. So these are some of the scenarios I could come up with, and I've quickly discussed with some people as well. but there's obviously many more that you could do. If you could have the complete flexibility to basically create those complex calculations, if all the data is available and up to date and accessible by everyone, by all the systems, to be able to use it to make their decisions. And if you are able to have the performance and the scalability to actually use the full extent of the data you have to do all this, to do all this on. Okay, then we've come to the final part, the Q&A part. I hope you enjoyed it so far. I tried not to go too fast because I typically tend to do that. Let's try and find the Q&A button here so I can have a look at the questions. Okay, can't use my mouse like this. Is there a difference between data processing and analytics? Is one of the questions. Well, yes and no. I think analytics sometimes requires data processing, sometimes it doesn't. So analytics is more looking at your data and trying to do simple data processing, like aggregating it up to find a certain number. But data processing itself can really, like your actual pricing can also be data processing. If you have everything at the half-hourly level, that is actually also data processing. Your long-term forecast is also data processing. Those things are, yeah, so that's more than just the analytics part. The analytics part is more looking at the data you already have. The data processing is creating more data or calculating on the data. So it's very similar, but data processing is bigger, I think, than only the analytics. And the data processing can actually also be all the cleanup of your data as well, as like anomaly detections or those type of things are also data processing. Is it possible to update different items in a data lake at different times of the day so that a real-time view can be achieved? So yes, that's definitely possible. It really depends on if you have a structured or an unstructured data lake or data warehouse or wherever. But it's definitely possible to update it from at different times. So you can really do it event driven. So once something happens, then you can update it. I think it's only very important around these things is about the rules, who can update what and where, and a lot about the data pipeline of it going in to manage that you don't get conflicting entries. But yeah, you can actually really go for a real-time view. That's definitely something that is very possible today, as well as even those big data lakes nowadays, because that's also something we do with Gorilla. You can actually, although there's huge amounts of data, you can actually still query that quite quickly. So it's not that you have to have a bad job to get the data. No, you can actually query it and you'll get it within a couple of seconds, even for larger data sets. If I want to read more on this, is there a good website to research this more? Well, we have some research in the beginning, and I can maybe, when I share the presentation with you guys, I can ask Willem to put some of the references in there for most of the beginning of the research. Then a lot of the other stuff about the challenges and the opportunities, a lot of it are things that we've actually learned by just talking to a lot of people within the utility industry as well as outside of the industry. And on the more technical side of things, yeah, we're actually, all of us, so the whole company, Gorilla, is really has a background in a technology agency where we used to build a lot of products for different use cases or companies. So that's actually where we have a lot of our expertise in how the whole technological and data science thing worked. But on those things. The internet is full of it. So okay. How easy is configuration of advanced scenarios? That really depends on yeah, how we typically approach this is you'll have some level of complexity and you'll have some level of flexibility that you'll need, and that it's constant a balance. And so if you want to have sometimes you want to have more configuration, so more flexibility, but that will also mean you'll have more complexity as well. So it's really in the beginning of these projects, if you want to do these advanced scenarios, it's really okay, how much complexity can you handle, how much internal expertise do you have to be able to handle this, and then we can actually make more and more configurable, so that the end user can do this, versus it being completely an IT project. So it's constantly keeping that balance between the level of flexibility you want versus the level of complexity you can handle, because you can make everything configurable, but then it will become massively complex. And we actually, at that point, we did look at historically some other pricing engines, and that's where some of them failed, is where they made it super configurable, but that made them so complex that people found it very hard to work with them. And if eventually they got it set up, they did not dare to touch it anymore because they thought it would potentially break things, because they couldn't really understand it anymore. So it's constantly keeping that balance. And how can Gorilla incorporate PPA pricing into its advanced scenario? Yeah, we actually been looking into PPA pricing recently as well. And PPA pricing, in essence, is creating actually some forward curves of how the energy is moving to get your prices. And then, yeah, it's a limited small set of the pricing that's done by suppliers. But it's basically it's a calculation on data. So if you indeed put that in the data processing part, then that can actually also be used by your pricing as well, and it can be used to make your energy mix a bit different. I think the interesting thing about PPA pricing was that it had an effect on your DUOSes and your BSUOSes as well, because the you were paying that based on your net demand. So that's why that was interesting at that time. Now that's changing to being more of on a gross demand, those costs. So they will become a little less interesting in terms of pricing them. They will stay interesting because most of the time these are more green, and you can prove that they're homegrown electricity. But in terms of pricing, they're becoming a little less interesting with the DCR coming up. Okay. Then I think those were all the questions that were here. If there are no additional questions, then I would like to very much thank all of you. I would love your feedback on the webinar. So it was our first one. We tried something. I hope it was useful to you guys. I hope you learned something. I hope you can take something away and do something with it. We'll probably send you a follow-up mail where you can maybe get the presentation and maybe a short questionnaire on your feedback. So I would very much appreciate it if you could actually provide us with that feedback. So thank you, everyone. If there's additional questions, don't hesitate to, after the webinar, just shoot me or Willem or anyone from Gorilla an email, and we'll make sure to come back to you. Okay. Thank you. Have a nice evening, and bye.